You're good.
Okay, I guess we might as well get started. Still a couple of the usuals not here yet. But I know Joe and Ken won't be joining us tonight. Okay, so tonight on the agenda we have we're going to talk about Pico balloons and then 4 days at Eric's cottage, and then if there's time, then we can talk with questions and whatnot. So I guess we'll get started right away with Dave, who we met down at 4 days at May, VE3 KCL, and a very avid balloon enthusiast. And I'm sure most of us here probably are aware to a certain degree with what he's been up to. Not in any great detail, I think, Dave. So we're really looking forward to hearing your experiences and how you're going about this. So without any further ado, if you're ready to go, Dave, over to you.
Sure. We'll see if this works. I've been trained by the other Dave and Peter, so maybe this will go more smoothly now. I live in Toronto. I've been a ham for 55 years. And in 2014, I messaged Hans Summers of QRP Labs when he was I think he was living in Japan at the time. And at the time, he got an email call. I bought one of his early beacon kits. And this was probably after he first introduced it in 4 days in May. And it was cheap and fun to build, and it just sent QRSS or CW, and it would send your call. It was very, very simple. And at the time, in 2014, he was developing the Ultimate 3 beacon, which is a kind of circuit board with a display on it. And you could program it to send Whisper or JT9 or Paul Schreiber. It would do a number of tricks, and he was always advancing the firmware, and he had got to version 308 on it, and that allowed you to use something called tags, where I was looking at JT9 as a possible transmitter for sending telemetry information from a balloon. And I hadn't flown a balloon, so I didn't really know how it was going to go. But it allowed you to use hashtag LT, and it would transmit latitude in JT9. So you could put a bunch of things down, and it would send latitude, longitude, voltage, temperature. It would also send an accurate maidenhead if you wanted to. It would do a bunch of things. So it looked like a perfect thing if I could use it to send telemetry from a balloon. So that's where it started. And JT9 is a 1 minute transmission, and it sends 13 characters. So I would combine my call with altitude, for instance, and it would send my call and then altitude and latitude and longitude. And so there'd be a normal Whisper call, which is a Maidenhead 4, which gives you a square about 70 by 100 miles, which is very difficult to track. I mean, it's okay if you're a ham radio guy to know where your station is, but you really need Maidenhead, 6-character Maidenhead to give you a more accurate location. And if you sent latitude and longitude, you could get it down to maybe 30 or 40 meters, which was very accurate. So this is what we were thinking about doing. And I told Hans of my intentions, and started ordering from AliExpress, where I could get a GPS module, and I was going to use his SI5351 module. And also, his circuit board was fairly large, so I found that you could just use his firmware in an Arduino Nano, which uses the same Atmega 328 processor, which is pretty well extinct now, but it was very cool at the time. It would do a number of things for you. So I got an Arduino Nano, and I don't know, maybe I can find some pictures for you as I'm going along here. Let's see what happens. I have to go down here for screen sharing if I can. Oops, I did something wrong. No.
Did he drop off?
Yeah, I think he did. Oh, there he is. He's back.
Okay, well, that failed pretty badly. Let me try again.
Yeah, you did it about 20 minutes ago.
Yeah, well, let's see what happens. Entire screen.
I think you hit the red button by accident.
Yeah, well, I got a P. I somehow I had clicked something. Now I go entire screen, click on it, and go share. Okay, there we go. All right.
There we go.
So let's go to the first flight, which has some pictures. Tell me if you can see everything okay.
Yeah, we're seeing whatever you're putting up on there, Dave. Okay. No problem.
So I had no idea about what to use for a balloon, so I went to the balloon supplier and got these really cheap. It was a retirement balloon for over the hill. And little did I know that a black balloon was a bad idea, because as it got up to altitude, the temperature, the sun would heat it up and increase the internal pressure. So that didn't work too well. But that's what we went with the first flight. And here's what it looked like. There's a tiny, I don't know if you can see my cursor here, but there's a tiny little dot, which was the radio. And here's the two black balloons pulling it up. And this is what the radio looked like. There's the GPS antenna went out to a dipole, and there's 8 solar cells that produced the power for the charging the battery and running the radio. And this was at the center of a 30-meter vertical dipole. So the balloon, one end of the dipole came down and hooked onto the top of this thing, and then top of the radio, and then out of the bottom radio, the lower end of the dipole went groundward. And here is what the first radio looked like. There was a GPS module for $6 at AliExpress. This was a battery, a boost converter that controlled the battery to make it 5 volts. It's because everything was running on 5 volts. There was a small lithium cell here that had internal regulation on it. So if the voltage went up above 4.2, it kicked out, and below 2.25, it kicked out again. This was the Arduino Nano that required a new 20. You can see a crystal there. It needed a 20 megahertz crystal on it to copy Hans's board. And this was the transmitter board, which had some level regulators for the I2C bus, and then it had a tiny little SI5351 chip in there that produced the output for the antenna. Now you've seen a 50 ohm load on there as we were testing it in this image. What other interesting things? Well, that's how it flew. It went up and came down in about 2 hours. It was disappointing, as it was supposed to go to 7,500 meters and went to 4,000, which probably meant the balloon burst. And let's see if I can find, just to make sure. Are you guys hearing me okay?
Yes, yeah, we are, okay. Dave. Do you want to take questions at the end, Dave, or as you're going on?
I can take them anytime as we're going along. So here's the second flight, which have some more pictures, and it shows you sort of how the telemetry worked. We didn't really know what I was doing, so I started sending out a CWID at 30 meters, 20 meters, and 17 meter bands on the 30 meter antenna. So it wasn't really wonderful, but we just wanted to see if we could hear it. And then JT9 was sent out, and it had the call sign and the altitude. These are the two for the first JT9 transmission. Then it had latitude and A0, which was probably voltage or something, and then longitude and A3, which was, I guess it was temperature for A0 and longitude for, for battery for A3. And then it had a standard whisper. And by this time, Hans had come up with a special type of telemetry whisper that we were experimenting with. And then we send out some more CW on 15, 10, and 6 meter bands to see if anyone would hear it. And then it would just repeat every 12 minutes. So that's how the second flight went. And the second, oh dear, phone's going off here. Oh well. So that didn't work very well. But by the time we got to the fourth flight, we had some success. Here's a map of where it went. It actually went right across the Atlantic, and it said telemetry, sent telemetry every day. It sent telemetry every day while the sun was shining. So this was a first. Nobody had, most telemetry is sent with VHF. So as soon as the balloon disappears off the coast, you have to wait till someone in Europe hears it. And this one transmitted day after day and allowed you to track the balloon across the Atlantic. And as far as I know, that was the first time that was ever done. And Hans was very pleased with what had happened. So here's the fourth flight. Little bit different layout. I had these little grooves put in there to transmit the heat because the temperature came up quite warm during the day. Who would have thought at 8,000 meters, the temperature would be room temperature in the box, but there's quite a bit of heat coming down from the solar cell on the top. So that's why there's the GPS, the battery. There's maybe a charging regulator here. I see something inside. This is a 5-volt regulator. This is the transmitter board that has the SI5351 in it. And there's an Arduino Nano with a 20 megahertz crystal that we had to bolt onto there to make it work, and then the adjacent wiring. And that one was an early success. There's an 8-panel solar panel, which was really bigger than was needed, we found out, but that was how we did it. Okay, that was the fourth flight. Then I'll just carry on. I guess it took a few more flights, but on the 11th flight, we managed to get around the world, which was a big achievement. We had telemetry all the way around the world, and let's see, maybe that's not the right one. Let me see if I can find it here. Yeah, that is the right one, I guess. It had gone around the world and then a little bit further. So started in Toronto and went around the world, and then came back, pretty well crossed over Lake Erie again, and then went over and disappeared over Russia. Now today's balloons use this kind of transmitter. This is the U4B, the latest version of the transmitter, and it's 1.8 grams. It's pretty small. This part here breaks off, and you just have a little rectangle, and it will transmit in high and low power. It'll transmit QRSS. It'll transmit FT8. It'll whisper and whisper telemetry, and then a new whisper called tele-N, which will send 2 6-digit numbers in addition to the regular telemetry, which includes the regular telemetry includes battery voltage, temperature on the circuit board, altitude, speed across the ground, and the tele-N will pick any one of the IOs and send some information of what you're putting into it. So you could have a different sensor on one of the input outputs of the unit, and you could send that in tele-N, which was an additional transmission. And I do that for spot count and a bunch of other things. So let's see if we can find some more information here. This is the other view showing the size of it, and there's the weight of it, 1.8 grams roughly. So it's quite light. You can build a solar cell and radio for about 4 or 5 grams, which is quite light, and that will float with a current balloon at about 13,000 kilometers or 14,000 kilometers, depending on how you prepare the balloon. This is how the U4B, the latest balloon item, operates as far as power is concerned. So I'll just walk you through the startup here. It has a sleep mode, which is the 4.6 volts. And in my system, it goes and it transmits QRSS for a minute or so, which is a balloon glyph, which I'll show you later, and an identifier. So people watching on QRSS, which is slow speed, a slow speed graph, will see the balloon and the flight identifier. Then it sends the first whisper message, which is 39 milliamps. And the second one, which for some reason is 2 milliamps less, we don't know. That's still a mystery that hasn't been solved. And it goes to sleep and waits for the next 10-minute cycle. And then it'll repeat again. And after, in my programming, it will wait for 3 low power cycles. And if it finds the right temperature, if it's warm enough, it'll go into high power, at which point it will send 27 milliwatts. Normally it's about 9 milliwatts on low power, and this is about 27 milliwatts on high power. It uses 56 milliamps, and there's the additional tele-N transmission, which sends additional information, and that information will, you can translate that and figure out what's going on. So let's go find a picture of that. I think we can go here. Let's go here. Let's get out of here. Okay. Let's see if we can find balloon tracking. Okay, so this is a map of the balloon tracking website on Hans's QRP lab site, and it's tracking the current balloon, which is U4B40. And U4B40 is sending low power transmissions, high power transmissions. It's sending a glyph, and it's sending tele-N, which is another bunch of information every alternate transmission. So it sends, I'll get you another detail, but if you look at the colors here, every lap is a different color. So it's as the first lap is brown. As we use the resistor color code. So the first lap was brown, and then red, and then orange, and then yellow. And right now it's on black, so it's on the 10th lap. It's been flying for about 190 days, 200 days. So it's doing fairly well. And it gives you some of the details here. Now, unfortunately, this is Moscow, and the GPS is being jammed heavily, so it's disappeared. It's not transmitting properly on today's date because the GPS spoofing. I don't know if we can see some of the details here, but if I go closer, where's Moscow? Moscow's one of these, and here it is. And they don't want us to know where we are, so it's been doing some tricks in not sending the right information. So it's spoofed the altitude information to 0, and it should be around 11,000 meters. It was the last location was KP9 1VR, and the battery voltage is 380 volts, temperature 2 degrees. GPS 0 means it didn't lock properly. And this is a whisper frequency. That's correct. It's in a band that uses a 20 hertz above the bottom of the whisper band. And there's only one report. Now, when things are good, you could be up to 80 reports per transmission. And so this is part of, go ahead.
Yeah, I was just gonna say, it's Peter. I was just gonna say, so maybe tomorrow start transmitting again or find itself because it's on further away.
Usually east of Kazakhstan.
Well, yeah, one of the stands.
One of the stands, yeah. And it starts working there. And near Moscow, it's very sensitive. And certainly going over Ukraine, it shuts off too. It's very unhappy around Turkey and here. It just shuts off and doesn't tell you where it is. You can see I avoided it here, but it probably, ended up disappearing and coming back. So yeah, GPS spoofing is a big deal for these things. Now, apparently U-Blocks has made one that can't be spoofed, which is, it sends, and the European system, which is Galileo, has a non-spoofing signal that sends along that they can't duplicate. It has some kind of trick, so it can't be spoofed. So spoofing is a new thing. There's actually an app you can go to if you Google it for GPS spoofing, and it shows you where all the because a bit of an issue with commercial aviation. A lot of guys are using GPS for flying planes, and it's not nice when you can't tell where you are. And they all have inertial guidance in them, I think, the big planes, but it is annoying when they spoof you. And they definitely spoof the American system more than the Russian one. I don't know if they spoof the Russian one. So if you're building a drone with a bomb on it, you're probably better off to use a Russian GLONASS GPS, because it probably won't give you trouble. Okay, so that's where the current balloon is. This is this was launched, as I say, about a couple hundred days ago, and I haven't been. I'll see if we can find some more information here. Where are we? So the first flight was 2015. We got around the world in 2016, and then there's a bit of history here. In the development, like we were, Hans and I, after the first flight, were continually talking about what we were going to do, and he came up with a system that wouldn't pollute the GPS data too badly, by only would have your call sign, but the second part of the transmission, which gives you Maidenhead, would change, and he'd send some data that way. So we basically sent a basic whisper transmission, and then 2 modified whisper transmissions after that. And that worked okay, but we called Joe Taylor and said, look, what do you think about this? Are we going to try? And I wrote him an email and said, we want to experiment with this because it looks like it might have an application. Certainly the vast whisper receiving network would be really easy to track something around the world. And these balloons, they get around the world pretty quickly, as fast as 11 days. And usually you get it around in 2 weeks or 18 days, so makes me think about if there was ever an atomic explosion. That wind goes around the world pretty quickly. There wouldn't be any chance of avoiding radiation, I think, if there was a nuclear issue in a part of the world. So we talked to Joe Taylor. He thought, well, yeah, give it a try. Go ahead. So then Hans realized that the ITU, the Telegraph Union, hadn't assigned a 0, 1, or a Q with call signs. So he said, well, let's use that. So he made a specialized whisper protocol that folded all the telemetry into a whisper transmission that started with a 0, 1, or a Q, and that made 20 channels. And that's since been expanded to 600 channels. So in the balloon world, using the Hans's QRP Labs telemetry protocol, you can have 600 balloons traveling at the same time, sending information, and they won't step on each other's toes. And that's done with frequency bands. Like, it was pretty complicated. He had to go and figure out, because all receiving frequencies are off. So he downloads all the data for 20 meters, and he corrects all the frequencies. And there's a place you can go to find out, see if I can get it for you. You can look at your call on 20 meters, and it'll tell you whether you're up 8 kilohertz, probably 8 hertz, or down 9 hertz, or up 150 hertz. He does it for everybody who's on the 20-meter band receiving. So he corrected all that stuff. So he had a database of corrected frequencies, and then he could look up the receive call, who received your balloon call, realize you're 8 hertz high, and then correct the frequency. And so that gave accurate balloon bands. So there's 4 in the 200 hertz wide whisper band. There's 4 40 hertz bands. In my case, the band I'm using is from 1497,000 to 1497,040. So I'm right in the middle of it. And then there's timing. So you could start on any one of the even minutes in a 10-minute frame. So you got 4 more that way, and another bunch that way, another 5, I guess, that way. So it started multiplying the number of bands, the number of free channels available for telemetry. And so it's quite workable. And if I go to a picture here of what it looks like today, we were the only game in town at one point, but this is what it looks like today. A lot of people are playing with these things. We've done some development on the different types of balloons, and now they're pretty reliable. The ones we were originally using were party balloons, and then we went to clear party balloons from AliExpress, and then we went to Japanese balloons from 2 manufacturers, one called Yokohama balloon, another one called SAG balloon. And I'm just going to have another one delivered today, which is slightly bigger. So we don't know if it's going to work yet. That'll be a test case to see if it'll actually float. But yeah, so for a $20 balloon and a $50 radio, and some hydrogen, you can get something to fly around the world for. My best flight's been 317 days, but there's guys that have been up for 2 years. So it's a lot of armchair coaching from watching your balloon go around, which is, it's really a lot of fun, actually, when you do that. So where are we here? SOAREX. Let me see, what else should I be getting to? So the balloon that went around the world, which was this one here, that would transmit from about 12 degrees. It has a flat solar panel like this, and it would transmit from about 12 degrees of sun. You'll see I went with I used to have coax on the GPS antenna, but now we just use a twisted, found that twisted wire was very close to 50 ohms, so that's what we're using now. It dispensed with the coax. And so from 12 degrees above the horizon, the thing would have enough power to start. And from 12 degrees before the sunset, it would fly and transmit steadily during that time. So on the 11th flight, the one that went around the world, had all these. Here's I'll show you some images here. The whole radio package was 12.3 grams. As I say, you can get that down to about 6 to 8 grams if you really try. There's a battery, 1.5 grams. There was a package. I chose to wrap it all in plastic, so in case there was moisture issues, but it probably isn't a problem. There's the Arduino Nano with the 20 hertz coil on it, and a very small on-off switch, so you could turn it on before you let it fly away. There's a bottom view. I was using a diode, but we don't use that anymore. That went a diode to the battery, and there's the on-off switch. There's the lower attachment that took the antenna. Now you'll notice it's off center and had to do with because of the way it balanced. It seemed to balance best here for some reason. So if you had, it was an off center device. We wanted to have the wire in a place where the thing would balance evenly, and that's just where it turned out. This is a Peltier cooler I built to test the stuff in the cold, because you really didn't know what was going to happen up there. At night, it gets pretty cold. And at least that's what we heard. So this was used a 3-stage water-cooled base and 3-stage Peltier cooler. So the top section up here was able to produce pretty low temperatures. So here we're at -52. And it used a server power supply. So it needed 20 amps or so to run at 12 volts to run all this stuff. But we were able to do the tests. Also, I needed to circulate the air, and I used a small helicopter tail propeller to try and circulate the air in there in the inner body, the center of the foam. And unfortunately, it got so cold that it wouldn't spin. So I ended up putting the motor on the outside and running the drive shafts through the back of the cooler into the space that needed air circulation, and put the propeller on the inside. So when it's running, it makes a terrible racket because you've got this tiny little motor driving a propeller on the inside. You don't hear the propeller, but the motor's making a terrible racket. So I don't run this very often. This is how that kit went together. This is one of the early ideas where we decided to make a single board unit, and I just tried a bunch of different tricks. We started, when in the development of the U4B, we first did the U3B, which was a single board, and the single board, one-sided single board, and we tried that to see if we could get it to lighten the weight that way. Because if we could use the smaller, yeah, we could throw away the whole board if we did that. And that was the interim stage. This is what it looked like before a flight. There was a couple of, here we're using silver Mylar balloons, which were sort of unreliable. But we found that if I'd gone around the edge seals with a band sealer and reheated them, they became much more reliable. So this is prior to the flight. They're filled with an exact balanced weight of hydrogen, so that when joined to the payload or the radio, it went up with about 3 grams of free lift per balloon. Here's a radio image. This is testing. This is the front of my house, and you had to check these things to make sure they transmitted. So that was just hung it from the front screen. And another image of the solar panel. Now, I can give you some ideas of construction here. See if this works. So I have a hydrogen bottle that has 2,000 pounds of hydrogen in it. So that's not very handy to have in the living room. So I transfer it to an empty propane cylinder. And this holds 150 pounds, which is well below the burst pressure of it. And this was one of the problems that I did maybe caused the first 2 flights to fail, because I kept purging I'd fill this tank full of hydrogen, and then I'd let all the gas out of it. You could still smell a little bit of, the propane essence. They put some kind of smell in there, so you're leaking propane. And we did that 3 or 4 times and launched the balloon, and it failed. And it turns out that propane sits at the bottom of the tank. And I guess had I known, I would have purged the tank by filling it full of hydrogen and then inverting it so the propane would go to the valve and then leave. So after I did that, after the first failed flights, I was getting pure propane and no mixture of, getting pure hydrogen and no mixture of propane in with the gas. So here it is showing, showing a 100 pounds. So you just take this and put it in the balloon and add hydrogen as required. The balloons are stored in a flat between 2 pieces of plywood. Here, these are the $1.50 Chinese balloons that we did many of the flights with. This is the newer type of balloon that is a spherical balloon. These balloons are oblate spheroids. They aren't really perfectly round, but these ones work out perfectly round. They're more money, but they're better weight to volume ratio, so they fly higher. This is a manometer, and what we found is you had to stretch the balloons first. And because if you set them off without stretching, they go up into the cold atmosphere and they wouldn't stretch properly and they were more brittle. So you had to stretch them to the maximum volume on Earth. And to do that, you had to apply pressure to them. And what I use is a $12 fish tank pump and a regulator, which I'll show you later. And it appears that the burst pressure is about 0.6 psi on these balloons, and you can fill them up to be quite round for about 2 to 3 psi of air. Then you take the air out. Now this is the regulator. This was actually like Archimedes here. It's basically a pipe filled with water and a tube that goes in and bubbles. And the further you put I've got a little clip here to set the depth, the further you push it into this column of water, the higher the pressure. So you want to set the pressure to a certain level, say 0.2 psi. So you'd set the manometer so it reads to 0.2 psi. And then you could walk away and it would regulate the pressure at 0.2 psi. And then if you want to go a little bit higher, you'd push that tube a little bit further down and watch the manometer and show you what the pressure is. Otherwise, people were blowing these things up all over the place. This was a very simple solution to solve that problem. Here it is, a piece of pipe with a cap on it, open end, and a piece that goes down inside and bubbles. So regulator. Here's the hookup where you hook it up to the balloon. I just found if you stuck a tube inside and wrapped it with a single rubber band and then held it so the band wouldn't come off, it didn't leak. So that's how we pressure test them. So you fill them up, get them to be the size you want, and then you leave them, you shut off the air and see whether the pressure holds. And if the pressure holds for 3 hours, then you know the balloon doesn't leak, which is a precaution. Otherwise, your balloon's going to fail in a day or two if it's got a leak. Here's the early testing where you'd do 5 balloons at a time, because you know you're going to do quite a few that week. So you fill them all up. And then I had a rig for measuring the size of them to make sure they were full enough. You just measure one of them, and usually that meant all the other ones are up to pressure, up to the volume of one. Here we go again. Let's see what else we have here. There's another, we found they also, the radio, if you were running it alone, it would run on 6 solar cells. So that was, here's some of the details. I don't know if you can see that tiny coil of wire, but basically I put a coil of wire in there attached to the radio so that if something went wrong on the antenna and you pulled it too hard, that coil would take up the shock and instead of breaking off. It was very disappointing if you broke a wire off on launch day, because then you'd have to take it all back. So here's the latest type of solar cell. Now it has, it will work right down to the horizon. A flat solar cell will work to about 12 degrees of sun. This goes right down to the horizon. And because it's pointed in many directions, it doesn't matter whether the thing's spinning around, it'll keep going. If you have a single facing one, it may be facing north or something, and you won't get the sun from the west. So this design, pretty heavy, 5.4 grams, but and underneath it has diodes, blocking diodes on each bank of solar cells, and it has a regulator on there to make sure the voltage is just suitable for the radio. Had to do some testing of the solar cells, so there was a couple of ways we did it. This is a grow light that seemed to produce quite a good result. Here's another radio where 7 cells were used, and this was the radio package that went on the bottom. This is another experiment we tried. We thought, now a Swedish guy named Michael, he's had success by using this. It's a roof-shaped collector and with a magnet. So the magnet tends to point the ridge of the roof north and south. So it would pick up morning and evening sun. For me, it didn't work. I didn't find it worked reliably, but and it works best in the fall, I guess. In the summertime, the sun's all over the place, but there's that much sun, it doesn't seem to matter in the summertime. This is the backside of the roof collector, whereby there's a small neo-medium magnet that points the ridge north and south. A couple diodes over here to block. This is the radio in this part of it, right? So these are these little coils that allow the antenna to flex. This is the glue I use, and you need something for foam. I guess guys who built model airplanes have their own favorite foam glue, but this works very well for balloons. And I also use it to hold the antenna to the antenna wire to the fishing line, which supports it. So this works quite well. There's another radio all ready to go for 4.96 grams, 5 grams. Testing on the roof. These are some results where you check the cells to see how they work on the solar angle, and you'll see that, I guess, this stuff is all available on the QRP Labs website. If you want to look for it there, you can check all this stuff later. There's another version using 6 cells. The other one used 7 cells of this triangle solar collector. And here's a U4B all wrapped up. Another example using 7 cells, flat 7 cells. This is how it's rigged up for testing at home. Another packaging deal. This is the antenna. Well, you get an 8 by 11 sheet of paper and roll it up, and then put a piece of foam on it. And so when you're winding the antenna on, which is about, I guess, 15 feet, the foam picks up the loose wires. Otherwise, they'll move around and slide. So you basically wrap the wire around this thing, and it becomes very stable. So you have to weigh your roll, and then you wind the wire on, and then you weigh it again to see what the wire weighs, so you know the exact weight of the antenna. The antenna is running about 0.8 grams or so quite light. Here's another example of the a pyramid solar collector. Now there's 3 diodes down here, just glued down. This is a LED, and the LED is used to catch the cloud reflection, and that's calibrated, and that's sent into one of the IOs of the radio, and it's transmitted as a reflection number. So what we got here. This is the simple $12 pump that I use to pump up balloons to pressure test them. This is a band sealer, around $25-35 that you use to seal the balloons with. After you fill them up with air, you have to evacuate them. So I have a tube. There's a tube here that runs through the center of the balloon with a bunch of holes in it. And I've modified the $12 pump, so it's also a vacuum pump. You just seal the inlet air off, and you drill another hole. And so it'll pull enough vacuum to pull all the air out of it, and then you pull that inner line out, and then suck the rest of the air out, and then seal it, and then that's ready to add hydrogen to it. This is a radio balance sheet, so you have to, the radio and solar panel weighs 5.6. The antenna weighs 0.65 grams. There's a bunch of tape and stuff on there, so I use 0.1 gram. Now, this particular flight had 2 balloons, so you have to share the payload between the 2 balloons. And the free lift was 7.5 grams. So it tells you want 7.5 grams and half the payloads, which comes to 10.68 grams. So you would put a weight on the balloon that weighed 10.68 grams, and then you would add hydrogen to the empty balloon till it balanced perfectly. And then you take those two balloons and seal them and get ready for the flight. If you leave them in the house too long, they'll start leaking hydrogen. So this was a simpler one. It only had 1 balloon, and it would be a radio of 4.96, an antenna of 0.6, miscellaneous 0.1, giving you a total of 5.66 grams, 7 grams of free lift. A free lift is the amount of extra lift you have above neutral. So you want it to have a pull up of 7 grams. That gives you 12.66, which you would make a weight of 12.66, clip to the balloon, and add hydrogen till you got the balloon balanced. This is morning before the flight, using egg beaters to keep the balloons on the table. This is the sealing process. After you put the hydrogen in, you'd put the fill port in the band sealer and seal it. Now I found that I use 3 seals, and I found that with a gas sniffer, if I just put 1 seal on it, somehow the hydrogen screws up the seal, and you could still smell some hydrogen with the sniffer after 1 seal. But after a second seal, it sealed it so there was no gas. And after a third seal, there was no leakage. But so I tried it the other way around, and I put this seal first, and I could smell some gas. And then I put this seal. So I was going, the seal was always being polluted by hydrogen, because the balloon is, I guess I should say the balloon is up here. and this is the entry port. So the if I went that way, I wouldn't get a good seal. So basically, you go from the inboard part of the balloon, make the first seal, and then the second seal, and then the third seal. This is how I attached it. Put a piece of Dyneema through a hole, and then glued it with the contact, the clear contact cement. This is how you join one balloon to another. I found that if you stacked them vertically, they went through the air a little faster because one would make way from the other, and you didn't have to worry about them bumping together. There it is, what it looks like before it's going to take off. Then you put both the balloons. I put them in a bag to carry them to the beach. And undoing the bag. And this thing here is just a piece of very fine plastic attached to a rod, a metal rod. So you stick that in the ground to get an idea of where the available wind is, what's happening. Because sometimes it changes at the last minute. You want to have the balloon blowing towards you holding the radio rather than blowing away from you holding the radio. So you just want to make sure which way the wind's blowing before you start. This is what it looks like going to this is the shoebox with the radio and the two antennas. Another version of that. That's what it looks like at the launch site. I lay an old tarp down, undo the lower antenna bit. So the radio's sitting here and the lower antenna's there. Then I attach the upper antenna to the bottom of the balloon, which has a string hanging out, and I tie a knot there. And then someone holds up the balloons, and I hold up the radio, and hopefully the wind is going in this direction towards me so that the balloon rises as I'm standing there, and it just takes the radio up out of my hand. That's the way it's supposed to work anyway. So it sort of looks like this. I'm holding the radio here, the balloon's up, and the wind should be going towards me. There's a launch, two balloons, and there's the radio. This one was pretty fun because the dogs were dying to get the balloon, but they didn't. We tried silver balloons, and they sort of trapped the heat and weren't as desirable as clear balloons. So you had to put less free lift in them, so the pressure was lower. This is a device to measure the amount of expansion. So it's basically a hoop of metal. And you'd slide the balloon until it was just at that height that you'd know you've reached the full capacity of the balloon. There's another shot of it, just reaching the top. This is what it looks like folded out and folded before you, or after it's been deflated. And this is still full of air for testing. This is just got some hydrogen in it, but it hasn't been stretched out yet. This is a launch where I'm holding the radio and the upper antenna, and someone else is letting the balloon go. There's a number of ways of tracking them. There's a thing called no high split. You can put the location of your balloon into this model and the location and altitude, and it will map it for 4 or 5 days. So it'll tell you where your balloon's going to go. And this is just an example of it. This shows you the relative altitude. And as it goes over Greenland, you see the altitude drops a bit because Greenland's 2,000 feet. Okay, well, let's see. I guess that's mostly it. I have some early pictures, but unless anyone wants to see it, let me just stop sharing here. Okay.
All right. That's great, Dave. Most interesting. There's a ton of details in there. You must have a nice fancy checklist so you don't forget something.
Yeah.
Got a couple of questions here, but I guess one that curious about is, has anybody ever found any of your balloons?
Well, I had one that just continually had a battery in it, and it kept pulling my call sign. It was down in Rochester, and Jim down there, he was dying to get the people to find it, and I was worried because it looked like it was right on the high voltage lines, and I didn't want to have anything to do with it. So I said, let it run out of batteries, because they had 3 or 4 giant power lines right down there, and the location showed me that that's where it was, and it wasn't shutting off, so I was hung up on something, and I said, no, let it go, because then it would have been a lot of trouble. But no, they've never been found.
Okay. And what about coldest temperature recorded?
Well, at night, well, right now I'm using a battery, and the problem with the battery is once it gets to about minus 35, it just gives up the ghost. The chemistry freezes and it won't do anything. So on the most recent flights, I built a parabolic reflector that points down at the Earth and focuses the IR from the Earth on the battery. And I've been getting much better life at night. So we've had initial transmissions of up to 6 hours of darkness, which has never been done before. The best I've ever done with a battery is about an hour. So with this reflector, it gets some of the UV from Earth, and it works particularly better if there's a cloud cover from Earth. I don't know why that works, but I can measure cloud reflection. So some of the tele-N, which is the extra telemetry, measures outside temperature, and it measures the cloud reflection number, which is an arbitrary number, and you can see that the temperature goes up quite a bit when there's cloud reflection, because I guess under normal circumstances the sun hits the clouds and they bounces back up under the radio and heats it up. Yeah.
Good.
So,
okay, thank you. Got some more questions here. First up is Eric.
Yeah, thanks, Dave. Great presentation. Any reason not to use Galileo by default?
well, I'm cheap. So I can do this for, well, I used to be able to do it for $20 with a $3 GPS. Now Galileo is usually, I mean, there's a couple of things. You can buy one that will do Galileo, but it uses more current. You have to assign a constellation to it, and they're usually more current. This one tracks for 17 milliamps, which is pretty low current consumption. And the ones that do multi-constellations are usually in the 30 milliamp range. So it's expensive on, you have to have a little bit more power from the solar cells to do it. And
there aren't ones that just do exclusive unit constellation for similar current draw? No?
I don't know of them. Galileo's the Euro one, right? So I don't know how it would work over Russia. It might work fine. I've never used it. I just used GPS, which has always worked, except for war zones and Moscow. It's funny. It's in Estonia. It's working fine. It's going to Finland. It works fine. It crosses the border in St. Petersburg, and then they're jamming it. So,
right.
Couple of days I run. It's not that exciting there because there aren't that many stations to listen to you anyway. At the western part there are, but once you get over Russia, there's not a lot of response.
Okay, thank you.
Okay, up next is Phil.
Yes, hello, Dave. That was very, very interesting. I used to track your balloons a lot a few years ago when I had a better antenna and everything, but we're in an apartment now. It's much more difficult.
Mm-hmm.
But I've tracked a lot of them as they've gone overhead and watched them go around the world on the internet.
Yeah.
A couple of quick questions. going over the UK, I understand you weren't supposed to transmit over the UK. And is that still the case? And if so, how do you handle that, or do you just sort of ignore it?
I ignore it. I mean,
But it is a
we
rule.
are from the colonies, of course, but you know, I think probably nobody's. I haven't got a letter from the Queen saying I've been bad, and I just went over the UK just recently. If you look at the map, went right over Scotland. But I assume it's the UK.
Yeah,
And,
you went over
you know,
quite a bit
in
of the
Ireland.
UK there.
Yeah, it's not. I mean, you think about it. Is there any good reason for it?
No.
It's just a rule, a Second World War rule that said you couldn't have any aerial bound transmitters, right? They didn't want to have anything flying over the giving away England, I guess. I mean, the fact that Ireland had big arrows pointing to England when the war was, when they were bombing, that didn't matter. But I guess it's still an old. It's hard to get these rules changed. So there is geo fencing that our balloon will do if you want, and you draw a box around where you don't want to be transmitting, and the U4B uses a basic program, and you can have the basic program check a bunch of maidenheads and say, okay, if it's between these, anywhere in this maidenhead block, don't transmit. We can do it if we want to, but I think it's very silly. I've transmitted over North Korea. Nobody's fired a missile at me. I mean, the only time they shot missiles was when the Chinese balloon was up there, and they took down one guy, I think, from America. They took down his balloon. And the one over where was it? Lake Michigan, I think. The Canadian jets went up to shoot it down, and they didn't have any bullets. So they got the American guys to do it. It was like a comedy. So you know, to use a $200,000 Sidewinder missile to shoot down a $30 balloon, it seemed a bit overkill, you know. And they had to worry about where that missile might land too. It was pretty scary. You couldn't just fire it off in a direction. It had to land in Manitoba or someplace where nobody'd get hurt. I mean, I'm not sure how they work. Maybe they explode, but it was sort of a comedy. It looked pretty funny from our amateur point of view. It's, you know, these people are defending Canada.
Another quick question. I noticed the latest balloon went around, I don't know, 7 or 8 times and stays in the northern hemisphere. It's amazing the winds like that. Have you ever had one of your balloons go into the southern hemisphere?
I have, yes. It seems to be, if you can get above 14,000 kilometers, then the winds get strange at that altitude. And I've had one go into the southern hemisphere, and a bunch of other guys have it. Like, the balloon technology is always changing. Matter of fact, I'm going to get a delivery anytime tonight of a bigger balloon at a lower price. So that's got to be tested. But yeah, the modern Japanese balloons will go to 14,000. And I've had one that was silver, and because of I hadn't accounted for the stretch, it stretched even more in flight, and it got to almost 15,000. And at that point, it crossed over in the Atlantic, crossed over to the southern hemisphere, and was flying around there for a while. But it had stretched so much that it had lost some of its integrity. Like the envelope film gets thinner and thinner, and I guess molecules of hydrogen can get out the thinner it is, or it has to crack a little bit when it stretches. Yeah.
Okay, thanks very much. Very interesting.
Okay, Drew, you're up next.
You bet. What a wonderful presentation. I love the whole thing.
Well, you guys got to get on the game. You know, you got to try it.
Well, yeah, it's not a hard sell, I'll tell you. I wanted to ask you a couple of questions. I hope I don't take up too much time here.
No.
How do you get permission to launch a balloon?
You don't
is there
ask.
a lot? Okay, I like that. I just wondered if there was a lot of.
Well, I think the rule is 2 pounds. You have to have a NOTAM, right?
Okay.
These things weigh
Nothing.
a couple of grams. And if you look at the damage they can do, you're looking at something that weighs, maybe a real heavy one would have first of all, it has no good center of mass. That solar cells are just like, you touch them the wrong way and they crack. So there's really no strength to them. It's on foam. It weighs less than an ounce. A real heavy one weighs an ounce. So we don't worry about collisions in airspace. And as far as I know, no one's lost one amazingly, but because it was flying in air traffic. I mean, they usually come down because they've run out of gas, or there's a leak, or high clouds will ice them up. I've lost a bunch to icing, and that's where high cloud will get up and put moisture on the balloon. It's got such a delicate balance. It's only got a couple of grams of free lift, and ice crystals will form on it, and then it comes down. And if you're lucky enough to have a battery and it's come down at night, the thing will start transmitting when it warms up, when it gets down about 2,000 or below the freezing level. The battery comes back on because the chemistry is all frozen. And then it starts transmitting. You get a play-by-play of its death or its recovery. And sometimes it recovers and goes back up to 8,000 or 10,000 meters, which is really a lot of fun when that happens. But if you can stay above 12 or 13,000 meters, the chances of clouds are very slim. I've been lucky on this flight to be fairly high in the northern hemisphere, so there haven't been any high clouds that I've flown through. If I'd gone through, some guys are flying through the central United States and Georgia and lower areas and lower latitudes, and they end up getting troubled by clouds, high clouds, hurricanes, and other things. But I've just been lucky on this flight.
I guess the last question I would have is bill of materials. And you mentioned Japanese balloons. I've seen some traffic. I follow the Pico balloon email, and the Japanese balloons. Now, these are all Mylar balloons or Tedlar, or what are they using?
No, they're made of they're called co-extruded, and they have a number of different layers joined together. The best ones that I know of are made by Japanese sushi makers, but these are different people who are making these things, and they basically co-extrude a number of layers of different material, and they have a very high gas, very low gas permeation, so they work pretty good for Mylar. I mean, if the thing will last for a year in space, I mean, up in the atmosphere, it's pretty good at reflecting the UV, which is damaging. And usually it's your stuff, your technique that's caused it to fail, or high weather, which can cause a problem.
So are most of them the bill of materials and the like? Is this
how
on
much?
the Pico balloon reflector?
Well, I was flying them when I was doing it. I went as low as $20 a flight, but I didn't count the demurrage on the hydrogen tank. So the tank used $90 cents worth of hydrogen, but to have one in your possession for a year cost you $200. So that part's not fair, but I used to be a welder, so I have a relationship with if you find a welder he can probably sort that out for you if you're trying to do it. Or you could buy pure helium from somewhere, but helium's sort of a depleting resource, so hydrogen flies better. It doesn't leak as fast, and
no, it's a better solution all the way around.
Yeah, I think it is. Yeah,
just keep the temperature low when you're sealing it.
Yeah.
Thank you. Again, I look forward to hearing a lot more about this.
Yeah, you guys should try it.
I'd like.
It's really fun. You know, that's when you get excited. Your heart starts pumping when you're letting this thing go. And then you get to watch for weeks, sometimes weeks and months, you know. And you can see, you learn stuff about there's a lot of physics involved too. If you want to study it, there's lots of interesting stuff going on that allows this stuff to work. Yeah.
Howard, do you still have a question, or did it get answered?
I got a couple of questions. Can you hear me okay?
Yep.
More or less.
Okay. So, Dave, couple questions. By the way, I posted the air regs in the chat concerning launching unoccupied balloons. I don't think there's a weight, it's size. How much cubic feet of gas you've got? Because I did way back, like, may have changed, but I launched like 10, 15 years ago. A large weather balloon went up to 117,000 feet, right? But anyway, that's not. So Drew, I think it's size of the balloon. The balloons of that Dave is launching is small enough that Transport Canada doesn't care. So Dave, that's my first question. Has there been any incidences of where a balloon has gotten sucked into a jet or has an incident with a jet? Because I think it's pretty lightweight. There's nothing there that would cause an engine to be damaged because it's all styrofoam and little wires on a tiny little circuit board. I think the biggest thing you got is the solar cell.
Well, and for weather balloons, I think they launch 250,000 per year, like every day at 12 and at 12. But they 11 o'clock and 11 Zulu and 11 Zulu and 23 Zulu, they launched weather balloons from all sorts of places. So 250,000 balloons a year, and no airplanes have been damaged by them. So these are big. These are things with about a pound radio hanging from below them. So I would really doubt if it could be an issue. Now, my friend is a designer for Pratt Whitney, and he builds, he worked on jet engines. He's now flying for Air Canada, but he had, I showed him and he said, well, no way, no problem. So this wouldn't hurt the engine. It's just nothing there, right? I mean, they fire chickens and stuff at those engines to see what happens.
Oh, yeah. Plus,
Yeah,
you'll eat great big hailstones, so if they can eat that without damage, I'm sure that balloon going through is not.
It's true, yeah. I suppose if you fire enough stuff at it, you can cause a problem. But this is, first of all, you'd have to. I mean, I did the math to see how a jet engine would have to find one of these things, and it's millions and millions to one for it to actually, like, the balloon would be nothing because it just goes through like a piece of plastic. It would be shredded away. But the center of mass is the radio, and it's a very small piece to hit. You can see when you're flying through a flock of birds, which are near the surface, it could cause a problem. You could ruin an engine, but I believe it's very, very remote that anything could happen. The engineer said there's nothing there that could damage an engine like that. So that was his opinion.
Yeah,
now,
that's what
I think if you asked for opinion, they'd say, if they asked them, they'd say no. So
yeah, and that's what I believe as well, Dave, because this thing is so small, so light that it's not going to do anything, and the fact that Transport Canada don't have rules around it, so I think it'll be. I think that's okay, and the fact that you can fly a 250-gram drone, without a license, and if that hitting an airplane could probably do a lot more damage than one-year balloons. And I think the worst thing that could happen if a pilot hits one-year balloon, you may scare the shit out of him because he's going like 300, 400, 500 miles an hour, and all of a sudden this thing appears and it goes right by him.
Well, my nephew flies for Porter, and he said he's seen balloons. He's seen flying along. You see balloons. That's just part of the deal. People are letting them go all the time. Kids are playing in the park, and then they're going. So they come by pretty quickly. Of course, you're going along at 200, 300 knots. So
Okay. So
I think it's a I mean, if you want to worry about it, you could, but I don't worry about it. I can't imagine the engineers defending that their plane had come down because of your balloon. I mean, that would be it would be very, very fragile. I mean, there are birds that fly at 10,000 meters and 11,000 meters, and they weigh pounds. So
besides,
the one that flies over the
anyway,
The Alps.
Yeah, I think it's a bigger concern at the major airports having a bird strike on landing and takeoff, because there's tons of those little birds in the summer. But anyway, horse is dead. Okay. Next question. The which is it's a two-part question. You showed a slide where the sky was just, well, wasn't the sky. The map was just full of balloons from other people.
Yep.
Okay, so those people, what are they using to fly the balloons? Is everyone using the same mechanism you're using, or are they using?
Well, I'm using the QRP Labs one, and it costs $55. But someone's come up with one you can build for about $20, and it works really well. It uses more current, so it's on a Pico something around. It uses one of the Raspberry Pis, and then someone built one that just is a Raspberry Pi Pico with a GPS bolted onto it, and that works quite well too. It's the cheapest one. So I think I don't think you can use a Chinese Raspberry Pi Pico, but you got to use a real genuine Raspberry Pi Pico. But they're only about $6 or something. They're very, very small and cheap. And yeah, that with a balloon for $15 or $20. I mean, we're lucky in Canada because the Balloons Online has these Japanese balloons for $16, and I had to buy 10 from Japan, and they cost almost $300 US for 10, so $30 each. It was pretty expensive, and so you can buy one for $15 or $16 from Balloons Online. And
so all in, how much does approximately, rough numbers, is the cost of a flight? It sounds to be it's probably upwards of about $80 per.
That would be reasonable, yeah. Mm-hmm. I think if you really wanted to go on the cheap, you could probably, we're using 50 balloons and stretching them, so the balloons would cost $3, and I think I was doing it for $20 a shot originally, because I made my own circuit boards and bought the parts and put them all together. I assembled the circuit boards initially. And it was a single-sided board, but it had the GPS and stuff, and it had Hans's firmware on it. But Hans's firmware now does all sorts of basic. I mean, it's a basic program, so you can have it do a number of things. I don't know if I can show you how it works, but basically, I let it. On the next one, it's going to transmit every 20 minutes instead of every 10 minutes every other day. So it checks the date, see if it's an even date or an odd date, and then it'll decide how it's going to transmit that day. And we'll see if the battery life gets better, if I can charge it more with more charging time between the transmissions, because every 10 minutes is quite adequate to keep an eye on your balloon. 20 minutes is fine too. So I think I think when I was over Ireland, I just got 110 spots on one transmission. And there were ones that went down to New Zealand, and amazing distance when you got an antenna sitting that high and the conditions are right. So yeah, it's pretty cheap, but if you want to fly a latex balloon, it's probably $300 or $400 per flight. You need much more helium. You need a big latex balloon, and you've got to put cameras and stuff in it, and then you have to go track it. You got to have a cell phone tracker or something on there to catch it, and it goes up to altitude, and then it comes down, and then you got to drive in your car to find it. So it's a lot of fun, but this is a lot more time for your money. Yeah, about $100 would be, certain things you buy once, like the manometer is about $30, and the fish pump, you buy that once for $12 or $15. And if you buy hydrogen, well, that's expensive, but you could go to a welding shop and talk to them and say, this is what you need, and you might have someone sympathetic. And you could get it done much cheaper. But the hydrogen content's about 90 cents per flight, so not huge.
So yeah, it sounds like yeah, the other pieces for the flight is not too expensive. It's the electronics. That's what's
Yeah,
gonna
yeah,
give
that's
that.
right. The electronics, and there's a cheap electronics. I mean, there's the if you go to the Pico website, you can find the cheap one. Like a guy named Rob is making them, and he's done all the firmware, and it will you just get a Pico and a GPS module and hook it up, and it'll fly. Now it needs more power. I think it needs 50 milliamps or 70 milliamps or something to run. So it doesn't go that close to the horizon because it needs a good shot of sun to fire it up. But it's just as good. It would work fine.
There's a guy at Hamvention. Is his name Dave Whitten, I think. He does, I think so, Whitten or Whitten. He does presentation on ballooning, and he does talk about Pico ballooning, and he does talk about a board. It's probably the same board you're referring to here.
Could be.
Could
be. There's a guy that has on. If you go to the Pico Balloon website, I mean not the website, the group. There's two guys that have made balloon transmitters after Hans, and Hans is. I'm using a prototype firmware on it, and the new firmware, the firmware that comes with the balloon, doesn't send the tele end message correctly. So unfortunately, I mean, you'll fly the balloon, it'll keep track of it, send all the rest regular telemetry, but you can't get the bonus telemetry to work. And Hans for 2 years has been so busy with the QMX and all that stuff, he's now putting SSB on it. So like people who bought this thing end up getting SSB for free later on as it's developing. And he's got so much stuff to do. He's like really swamped. So the balloon project is taking the back burner, but he's going to be putting the basic program onto the QMX because there's lots of room for it, and that'll allow you to program your QMX so it'll do all sorts of trick things, specially trick things. You can set up all the controls using the basic program. And he says when he has to work on the basic again, he will fix the basic on the balloon transmitter, so we can look for some new stuff there. But that's it's a bit disappointing that he hasn't found the time to fix it. But right, people are flying other things. I think he sells. I think he said 10 a month or something. Not very many. So it's not as exciting as the other products. I guess he has to make some executive decisions on how to use his time.
Yeah. So Drew, are you into doing a launch? Maybe if we get 3 or 4 people, split the cost, we could do a launch.
Well, I think it's a great idea to look into. I'm very keen. I wanted to ask about balloon stretching and the manometer hookup and this sort of thing that you had. That was quite intriguing, but I'm afraid I didn't catch it.
Okay. Well, I don't know if I can get.
What pressure do you put in it to start with? What do you run
Let
up
me
to?
see if I've. Oh no! I just did something bad. Let's go back here. Okay.
I think you mentioned something about 0.2 psi or something.
Yeah. Let me see if I can get this. I clicked the wrong button. Anyways. Can you guys see and hear me still?
Yep.
Okay. So I might see if I'm sharing the screen. Let me see if I can find. If I go here. Just bear with me here.
I mean, if we launch it over Lake Ontario, they'll probably shoot it down as it gets near Fort Drum.
No, they don't. They don't seem to. They don't do it.
I think they've stopped shooting down amateur radio balloons. They got a little embarrassed.
I think it was So here's a stretching rig for one type of. Can you see that? Okay.
I don't see it. No.
Can you see an image?
Nope.
Not yet.
Oh, what have I done wrong? Now let's see if I can get sharing it. So I'm not sharing this image.
No.
Okay, let's go back and figure out what I did wrong then.
Yeah, you're not sharing anything. We're not seeing a share screen at all. We're just
Are
looking.
you seeing me? What are you
Yeah, we're
seeing?
seeing you, but you haven't shared your screen yet.
Okay, so I have to figure out how to get back. Okay, let's try again.
Share entire screen.
There we go. We got it here. Entire screen. Okay, let's try again.
There. Now you're
Okay,
starting.
so
There
this
we
is
go.
this is a stretching rig that tells you how I
Okay.
did it with EMT. Then I have a little bit of a device here that slips down. This is just one of them. You put this down on this part,
Yeah.
and it shows you the vertical height of the balloon.
Right.
Let's see what we got happening here. So that sits on top, and it shows you it's 22 point whatever is 8 millimeters. And there's a device for. Oh, wait a sec. Where's the manometer stuff? I'll get another picture.
Yeah.
I guess I picked the wrong one. Let's see if we can find something else. Okay, so it depends on the balloon. I'll just
Oh, I see.
just-
You've got it on the QRP website.
yeah, it'll be it will be
Okay.
in there. But
Okay.
I'm just looking for the part that it might be in here. We'll just go see if it's here.
I guess the principal question for me is the pressure that you
Yeah.
tested on.
Well, if you go for the really cheap balloons, you can still get them from AliExpress at about $1.50 each.
Well, I
So
thought the
you use-
Yokohama balloons looked okay.
Okay, then the cheapest place to get them is from Balloons Online, and they're SAG balloons, which are basically Japanese balloons made in Japan. And you ask for the clear ones, and they're about $15.99 a piece or $16 a piece. And then when you now I do it differently than everybody else, and I use high humidity. I get 70%, and I run a bunch of humidifiers, and I get 70% humidity because I find the balloons stretch better first, and they come apart better. The Japanese balloon has 4 gores, and which are basically folds in it that make it form a sphere, and it's very tricky getting those apart. So you start putting a little air in them, and then if you just crank the air to them, it puts a lot of tension on the gores, and the gores are the parts that are held together by I guess it's some kind of laser sealing business, and they don't come apart easily. So with high humidity, they come apart more easily. So I get a little pressure in the balloon, and then I hand separate the gores by trying to get my finger in there and pull them apart. Once they're all separated apart, I fill the balloon up, and then in high humidity, like 70% humidity, I find that the balloon will stretch to full. You stretch it till almost all the wrinkles are out of it. And that, in my case, is about 0.2 psi. But some guys stretch them in dry air to about 0.6 psi. And sometimes they fail when you do that because it puts so much stress on the components, an uneven stress. What happens is this plastic is, I don't know what they call it, deliquescent or something. Anyway, it absorbs the moisture and becomes softer. And it makes it easier for the balloon to accommodate the change in shape. So
and that's at room temperature.
So 0.2 psi, or till all the wrinkles are out of it, or most of the wrinkles out of it, and it has a diameter of 100 inches. So if you got a tape measure and you're good at holding it in place, which is very difficult to do, you can wrap it around, or you can put it under a metal thing like I did that measures. I go 33 inches or whatever the diameter is. Circumference is 100. The diameter is around 30 something.
Yeah.
So you make sure all the wrinkles are out of it and it's about the right size. And then you hold it there for 3 hours.
Right.
Make sure it doesn't get too much smaller. You keep the pressure on it, and you keep it at 0.2 psi, or I drop it down a little bit, like 0.15 psi, because I don't want it to stretch anymore at 0.2, because it's a dynamic thing. And then you just wait to see. As the heater comes on in the winter, the pressure is going to go up and down. So you have to sort of eyeball it a bit to make sure that as the room temperature increases, the pressure inside the balloon will increase.
Sure.
And as the temperature
But
drops,
you're doing this you do this all at room temperature normally, and just in the
yeah,
summer.
it's not a problem in
Yeah.
the summer, but in the wintertime, if you've got some other thing happening, like air conditioning or something going on, it's going to change.
Well,
You try and
0.2
get,
psi isn't much as a few inches of water, so that's pretty good.
yeah, so it's very low pressure.
Yeah.
And the burst pressure is about 0.6 psi, 0.6,
Really?
0.7. So you have to, there's a float spreadsheet you use that determines the pressure at float, and you add the free lifts to get a reasonable pressure at float. So if the pressure is too high at float level, which is like 13,000 kilometers, 13 kilometers,
Right.
it can cause a problem. So,
and that spreadsheet's on the Pico balloon.
Let me see
reflector?
if I can
That's
find
okay.
it.
I don't want to monopolize your time here. I have
It's
to go do
okay.
some research before I ask any more questions. But that answers part of it. Is just these are fairly fragile.
Let's see if I can give you an idea of the what happens here.
Yeah.
Well, this is sort of interesting. This is here we go. Some complaints about non-compliance.
Yes.
Here's the balloon. This row that I'm showing you is the spot number. So it transmits the spot number every other time. So 1, 3, 5, 7, 9. You see the spot numbers going up, and then the outside Celsius. This is failed. This is a battery volts in millivolts. It applies it runs the voltage through a divider, and puts a 20 milliamp load on it and checks it for about 10 minutes and gets a very accurate voltage from the battery. And here's the altitude in fairly, normally it's just accurate to 20 meters. This is accurate to 1 meter, but here we're dealing with the Russian jamming. So it went from 11,000 to 376 and 11,000 to 328. So Russian jamming happening here. This is the GPS lock time. Now, 99 minutes is a time, 99 seconds is a timeout. Normally, it's about 16 seconds to lock. But when it gets above 16, you're dealing with some jamming. Here's some more jamming happening here. 99 seconds means that that's more than, that's the maximum time. And it just gives up. It can't get a lock. And this is the power mode, high and low. So let me just go back. Let me close that and try and get you the spreadsheet, because the spreadsheet's interesting. If I can find it here, float one. Okay. Okay, so now we got more complaints about compliance. Okay, so this is the balloon that's flying right now, and you enter the information that you have now.
Yeah.
This is the weight of the balloon, 48 grams. This is the volume. This is volume of the balloon. You basically calculate the volume by looking at your altitude that's being reported. And the payload weight was 27.9. The gas type is hydrogen. The free lift is 7. And then this number, like if this was, this should be 2.27 cubic meters, but for some reason, it didn't stretch. Like if that's the maximum stretch, should be 0.27, but it's showing 0.25. And I did that by adjusting the altitude. Like if it actually went to 0.27, I can change that and it will show a different altitude. Yeah, it went to 12,000. So because it's flying at 11,000, it allows me to determine by this spreadsheet what the actual volume is. And if it had stretched to 0.27, it'll show me what the pressure inside the balloon is, which is 0.24. I stretched the balloon to 0.2 to get the maximum the wrinkles out of it. So I would think that's a little bit too high because it might stretch. So if I go to 0.25, which is what 0.22, I think 0.225, it shows me the altitude lower, and again, the PSI is fairly high. Now we know that it bursts at 0.6, so it's probably fairly safe in there.
Yeah.
But it gives you an idea of what's going on. So it's fairly useful that you can change gases here.
Yeah.
It gives you specific densities of gas, and sometimes you get 97% helium, and sometimes you get full helium. And this goes and calculates the temperature at that altitude, which should be minus 56 C. So you can get this on the website.
Yeah.
Find a link to it. So let's say, yeah. So that's how the float spreadsheet works.
Very good.
It does the math easy then.
Well, it makes it a lot easier. There's still a lot of reading to do, but you've given us a pretty good leg up on how this works. It's
Is there any other questions for Dave? Michael.
Balloon goes to 11,000 meters.
We missed the beginning of your question. Try again, Michael.
Dave, how long does it take for the balloon to get up to the height of, let's say, 11,000 meters? How long does that take?
About 3 hours, 2 to 3 hours.
Oh, okay. Okay, thanks. That's good.
Yeah, fairly quickly. You, I think it's 8 meters per second or something like. No, I can't remember. But you can check every 10 minutes. It's gone about 600 meters, I guess. So whatever that works out to, 6 to 8 meters per second per minute.
And another quick question I had. There was the big propane tank that you were putting hydrogen in. It starts with propane. You vent it out somehow and put the hydrogen in instead. Is that what you were doing there?
Yeah, my first 2 flights failed, and we seemed to be something wrong. Well, could have been the black balloon that got in the sun and overpressured it, or it could have been the fact that there was propane mixed with the hydrogen. And when that happens, you need more hydrogen volume to get the same free lift. And so I would have overfilled the balloon. So when it got up to altitude, it was overpressured. So when I purged the tank, I filled it full of hydrogen and then opened the valve and let the hydrogen and what I thought propane come out. But what I hadn't done is inverted the tank, filled it up and inverted it and waited for the propane to settle to the valve, which would now be on the bottom. And when I did that, the propane came out first. And after a couple of purges that way, everything worked fine. So it's just, if you have previous, in a normal, if I'd been filling a hydrogen tank with it, there wouldn't have been a problem. But since I was filling it with a dense gas that is heavier than air, it stayed in the bottom of the tank. It didn't want to come out. So it would be heavier than air and heavier than hydrogen, so it mixed. And just inverting the tank and purging it fixed the problem. But I was so new at this, I didn't know what I was doing.
Okay, thanks.
Any other questions? Okay, Dave, that's a fantastic presentation.
Oh, great.
Information is in there. Looks like a couple of guys are interested here. So, and I think they know your address. So
sure, yeah, you can give them my email if you want, and if they have any questions, sure.
Well, I'm sure you're good in QRZ, right?
Yep. Yeah, I guess so. Yeah.
Yeah.
David, sorry to interrupt, but you want to stop sharing your screen?
Okay.
Okay. Again, thanks very much, Dave, and look forward to seeing how you make out with your next launch. Oh, when is your next launch?
I haven't determined that. We've got, you know what? Maybe let's see if there's a package in the front door.
Yeah, Dave lives in the beaches, so I think probably he launches down there at the bottom end of
down on the beaches. I
Yeah.
used to live down there.
Pardon me?
I used to live down there years ago.
Yeah, so did I, but I didn't know Dave then.
Oh,
Ah, yes, there's a package in the front door.
Do you launch just down the street from yourself there on the?
Yeah, I do. I right on the beach, but
I love it.
yeah, if you get up there early at 6 in the morning or 7 in the morning before there's too much wind, or there's a park nearby.
Yeah.
If the wind is from the south, which sometimes it is, it's not a good angle. So the wind at the beach, it would blow towards the trees. So that doesn't work. So if it's winds from the south, I go to a park nearby and launch there.
Okay, good. Well,
okay. So yeah, I don't know when the next launch will be. And it will probably be a battery one with a parabolic reflector on the bottom. And we're going to try for some night transmissions.
mm-hmm.
I'd love to see a drawing of this parabolic setup.
I think I can give you a picture here if you want. Well, no, something bad will happen, I'm sure. But yeah, it's basically mylar cut into 4 gores of mylar and heat sealed together. So it's a parabola. It weighs 2.9 grams, and there's I use a very fine guitar E string in the outside circle part of it to create a round part, so it stays round, and then another band of the E string further in. So there's 2 circular reinforcements in this, and then I glue it to the underside of the solar panel, and I paint the radio box black, and it takes the heat, the sun, hopefully, not the sun, the IR from Earth. Like most people know that there's a kilowatt of IR coming from the sun every day, but they don't know that there's 400 watts of IR coming from Earth every night. So there's quite a bit there that could be focused on they keep the battery warmer. That's what it seems to be doing.
Those results, Dave.
Well, Peter's got extra E strings, I'm sure.
Yeah.
Yeah, I do have a few strings lying around. They're doing nothing. Yeah, you're right.
Thank you.
Yeah.
That's a big help.
Okay.
Well,
all right,
good night,
thanks again,
gentlemen.
Dave. Much appreciated.
Sure.
I guess we ran on a little bit, so I don't think we'll talk about the 4 days at Eric's Cottage. So what we'll do is we'll do a posting, and then those that are going, I guess we'll just do it by Groups.io as to what we're going to be doing or what you'd like to do, that kind of thing. And actually, that reminds me, 4 days at Eric's Cottage starts
on the same day as our,
so
right.
Some of us, I don't know who's all going on the 6th, but anyway, we'll see how that
we'll
works.
have a remote.
Yes, I think so.
Yeah.
Good idea. Okay. So I guess with that, we'll say 7-3. Thanks everybody for joining us tonight. We had 13 out tonight, and it's good to see. And a couple of guys came out we haven't seen for a while either. So that was good to see you as well. Okay, guys, we'll catch up with you later. Cheers. Good night.
Good night.
Good night.
Thanks again, David.